Hello and welcome to Sleepy Scientist. I'm glad you're here, whether you've had a long day, a busy mind, or you simply love falling asleep to the sound of science. Tonight we drift together into one of the most ancient stories your sky can tell you. Imagine lying on your back in the soft grass, the night air cool on your skin, the scent of earth and distant flowers wrapping around you like a blanket. Above, the stars are scattered like grains of sugar on black velvet. But something is missing. There is no familiar glowing disk, no pale companion hanging among them. The sky feels a little emptier, the darkness deeper. You are looking up at the Earth's heavens before the moon was born. And as you listen, maybe picture where you are now in the world. What time is it there? I'd love to know. Drop your location and your local time in the comments below so we can see this sleepy little gathering stretch across the globe. If you enjoy these sleepy explorations, I'd be so grateful if you gave the video a little like and tap that subscribe button. It helps more sleepy scientists like you find their way here, and it means I can keep making more of these journeys for you now. The world under your back isn't the world you know. It's younger, only about 50 million years old, a mere infant by cosmic standards. The continents you know haven't formed yet. Instead, the surface beneath you is a restless sea of molten rock still cooling after the planet's fiery birth from the dust and rubble left over from the sun's creation. Volcanoes bubble and roar like cauldrons. Rivers of lava snake across the surface, hissing and steaming as they meet boiling seas. If you could smell the air, it would be metallic and sharp, heavy with carbon dioxide, water, vapor, sulfur. You'd pull your blanket tighter around yourself, not from cold, but from the weight of imagining such a place. Above this hot, breathing world, the night sky holds no moon to soften the darkness. The stars look almost too sharp, like shards of glass embedded in ink. The Milky Way is a bright river overhead, its light uninterrupted. Without the moon's gentle pull, the tides are smaller, the seas more still. Yet the whole earth seems to sway, waiting for something. It's hard to imagine, isn't it? You've lived your whole life with the moon as a constant companion. Maybe you've watched it slip silver over the ocean's surface, or rise like a lantern over rooftops. But here in this ancient night, it's not yet been born. The sky is unclaimed, and the earth spins faster. Days here are only about 6 hours long. Imagine how quickly the stars would wheel overhead, how fast night would give way to the next blazing sunrise. You might ask yourself, what will change this? What could bring a moon into being where there is none? The answer is already on its way, crossing the dark between planets. But here for now, you can simply float in the stillness before the story turns. You breathe in deeply, letting your mind wander over this scene. The earth below is like a drum, its surface shivering with the vibrations of its molten heart. The air above feels charged, as if the universe itself is holding its breath. Even without the moon's glow, there is a kind of beauty here, raw, untamed, almost shy. If you close your eyes, you might picture Earth from far away in this moment. A small, glowing sphere streaked with orange magma, wrapped in a gauzy haze of atmosphere. The blue seas are not the calm oceans you know, but boiling expanses constantly remade by volcanic heat. From that vantage point, it looks lonely, turning quickly lit on one side by the sun, the other half a dark hemisphere waiting for its first moonrise. And perhaps if you could stay up there in space just a little longer, you'd notice a tiny spark in the distance, no brighter than a wandering star. That spark is moving slowly but surely toward the young Earth. It doesn't know it yet, but it will change everything about this world's nights, tides, and even its life to come. For now, though, you just rest in the quiet, in the deep velvet night before the moon existed. The grass beneath you in your imagination might not truly have grown yet in this young world, but for your dreaming mind, it is there soft, cool grounding. The stars wheel on in silence, the air carries the ghost of a future song the oceans will one day sing when the moon arrives. The moment hangs fragile as a dew drop before history tips forward. The earth beneath you is not the calm blue marble from your postcards and screensavers. She is restless, wearing a cloak of fire instead of oceans and forests. The crust is thin, fragile, and constantly remade like a pie crust that keeps breaking and reforming under invisible fingers. Vast swells of molten rock pulse upward from the mantle, bursting through the surface in fountains that glitter red and gold. If she could speak, Earth would sound like a fevered storyteller, breathless, always moving every sentence, interrupted by the roar of new creation. You can almost hear it now, the hiss of steam, as rivers of magma meet the water, the low thunder of tectonic plates that have barely learned to exist, grinding against one another. Sometimes the whole planet shudders, as if it's still stretching into its own shape. And she is. Earth is only a few tens of millions of years old, just enough time for the surface to start forming a skin, yet young enough that her heart beats fast and her molten blood runs close to the surface. You might ask yourself, how does a planet even begin to settle down? What slows her spin, calms her storms, smooths her fever? The truth is, she isn't ready to rest yet. The very forces that built her are still at work. The sun's energy pounds her. By day, solar winds batter her atmosphere, and the leftover debris of the early solar system still rains down in streaks of fire across her skies. Close your eyes and imagine the sun in this era, not the soft golden disk of today, but a brighter, harsher glare in a slightly smaller sky. The Earth is spinning so quickly 6 hours per day that the sun rises and sets 4 times in what you now call one day. The seas, still young themselves, churn under strong winds and restless heat. Without a moon to tug them into rhythm, their waves are irregular, driven more by storms than tides. And still, the impacts come. Some are the size of city blocks. Others are mountains flung from the far reaches of the solar system. Each strike melts stone carves, craters, and sends plumes of dust high into the sky. Earth absorbs these blows like a boxer still standing in the ring, dizzy perhaps, but unbroken. If she were a character in a story, this would be the chapter where she proves her stubbornness. Yet in all this chaos, she is beautiful. From above, her oceans glint like pools of molten metal swirling with clouds of steam. The continents to be are just scattered volcanic islands glowing against the darker seas. Lightning crackles in colossal storms that wrap halfway around the planet. The air smells of mineral sulfur and salt like a forge by the sea. Somewhere deep beneath those molten plains, crystals are slowly forming. Iron is sinking toward the core, locking in the magnetic field that will one day shield life from the sun's worst tempers. Silicates rise cooling into rock, laying the groundwork for mountains that won't exist for hundreds of millions of years. And yet, she is not alone in her story, not really. Out there millions of kilometers away, a quiet traveler is moving through space. A world the size of Mars, made of rock and metal, its own crust cracked and marked from earlier battles. If you could see it now, you might call it scarred, but determined. Its name, which it doesn't know yet, is Theia. Theia is not a comet's fleeting whisper or an asteroid's brief flicker. She is a planet in her own right, with gravity strong enough to hold herself together, strong enough to pull on Earth when they finally meet. Her orbit is slow and stately, but fated to intersect with Earth's. Like two dancers moving on a dark stage, they are drawing closer without quite realizing it. It's strange to think this early Earth, and this wandering Theia are siblings of a sort, born from the same swirling cloud of gas and dust around the newborn sun. But their paths have been separate until now, and in the quiet mathematics of gravity, their separation is about to end. If you lean into the silence of space in your imagination, you might feel the faintest hum between them, like a low note played on a string. It's the sound of inevitability, the music of orbits converging. The Earth spins faster than you've ever known it. Theia drifts closer each moment. Neither can change course. And so, under this restless sky, with molten rivers and fire-lit storms, the stage is set. Earth waits without knowing she is waiting for the meeting that will change her forever. Out beyond the swirling blue and orange sphere of young Earth, Theia moves steadily through the dark. She is smaller, about the size of Mars, but still a world in her own right, with her own valleys, ridges, and scars from long-forgotten impacts. Her surface, like Earth's, is marked by the violent childhood of the solar system. Ancient craters stretch for hundreds of kilometers, their rims softened only slightly by the slow creep of time. If she could sigh, it would be the sigh of a traveler who has been on the road for far too long. Theia's journey hasn't been entirely lonely. She has passed by other planets in the making, smaller bodies of rock that pulled on her slightly with their gravity, tugging at her path, like curious children tugging at a grown-up's coat. But none have slowed her enough to keep her. She keeps moving, bound to the sun, yet drifting steadily toward Earth's orbit. You might ask yourself, why is she coming here at all? In space, nothing happens without a reason, even if it looks like coincidence. The answer lies in the slow ballet of orbital mechanics. Theia's path is shaped by the invisible threads of gravity, the sun pulling her inward. Other planets nudging her here and there, and Earth's own gravity reaching toward her across millions of kilometers. Little by little, those tugs have brought her onto a course that can only end one way. In the dark, Theia is quiet. No atmosphere to carry sound, no oceans to murmur against her shores, just the silent passage of rock and metal through the void. But her presence has weight. As she nears Earth, her gravity already begins to whisper across space. Tiny fragments of rock in her path adjust their course toward her. Dust streams bend around her bulk. It is as if the universe itself is making way for what's about to happen. From Earth's perspective, Theia is still just a bright speck among the stars, one of many moving points that appear and vanish with the turning of the world. But in the cold mathematics of space, they are on a slow-motion collision course. If the two worlds were people in a crowded room, this would be the moment their eyes meet from across the floor, still far apart, yet unable to look away. Back on Earth, the restless surface continues its endless work. Volcanoes bubble like cauldrons. Rivers of molten basalt carve their way toward the sea, steaming violently as they touch the boiling water. Storms rage under a young sun that seems a little too close, a little too bright. Days are short, and the horizon turns over and over in a dizzying rhythm. If the Earth could feel nervous, perhaps she would be now some instinct deep in her molten heart, sensing that something massive is drawing near. But Theia does not rush. In space, even a meeting of worlds takes its time. Each moment she drifts closer, the pull between them grows. Their orbits are like two spirals, slowly tightening into a single point. The gap shrinks by thousands of kilometers each day, but in the vastness of space, it still feels like a patient approach. Imagine yourself hovering in the space between them now. On one side, Earth spins furiously, glowing with volcanic heat. On the other, Theia glides with slow determination. You feel the invisible tug from both directions, your body caught between their competing pulls. There's no sound here, just the sense of two great presences moving toward each other in silence, like enormous ships on a midnight sea. What will happen when they meet? Will they merge peacefully like raindrops on glass, or will they shatter each other, flinging their pieces into the dark? You don't yet know, but you can feel in your bones that whatever comes will change everything for both of them. And so, the distance closes. Theia, the wandering giant, approaches with the inevitability of a story whose ending has already been written. Earth, restless and molten, spins faster, unaware of the companion about to rewrite her nights forever. In the dark expanse, the space between Earth and Theia narrows until their gravity begins to speak in louder tones. You can imagine it as a soft, deep drumbeat in the fabric of the universe, a rhythm that grows stronger with every passing hour. Theia's path curves ever so slightly, as Earth's pull reaches for her like an invisible hand. And Theia answers in kind her own gravity, tugging back, slowing Earth's spin by the tiniest of fractions, an effect so small that only the patient clockwork of celestial mechanics notices. It is not yet a headlong rush. No, this is the slow tightening of a dance, the kind where both partners begin circling step by step, feeling the other's presence, testing the distance. You might picture them as two enormous dancers in a vast empty ballroom, their feet never touching the floor, their gowns made of fire and stone. The closer they come, the more their gravitational pull stirs things up. On Earth, tides rise a little higher, not from the moon, for she does not exist yet, but from this massive visitor pulling at the planet's seas. Even the molten mantle feels it, shifting subtly under the crust, like a restless sleeper tossing in bed. If you could stand here, you'd feel a strange, slow sway, though you'd have no words yet to describe it. In space, the effect is just as dramatic. Theia's course begins to bend more noticeably, her path drawn inward by Earth's pull. She is no longer a distant traveler. She is a captured guest, spiraling ever closer. The sun looks on, unmoving in its brilliance, as two of its children prepare for an embrace unlike any other. Perhaps you ask yourself, do they know what's coming? Can a planet feel anticipation or fear or longing? If they could, maybe this is the moment they would feel it most. Theia has wandered alone for millions of years, and Earth has spun in solitude just as long. They are about to touch for the first time, and the meeting will be both beautiful and catastrophic. Imagine hovering just above Earth now. The young planet turns beneath you, glowing faintly with the heat of its own making. On the far horizon, a tiny dot has grown larger over the days, Theia no longer lost among the stars, but a world with craters and shadows visible even from here. Her approach is majestic, silent and unstoppable. Theia, for her part, sees Earth growing ever larger in her sky. The swirling clouds of steam and ash, the glowing rivers of lava, the deep shadows of volcanic basins, all of it rolls into view as she draws near. There is no blue-green marble yet, no snow-tipped mountains, no swaying forests, just a molten, restless sphere spinning with dizzying speed. And still Earth pulls her in closer. Now the space between them is small enough that the pull of gravity is no longer a whisper, it is a command. Both worlds accelerate toward each other, their paths locked in a spiral they cannot escape. The slow dance is becoming a faster one. You might feel it in your chest, the way music begins to quicken before the final movement of a symphony. If you listen closely in your mind, you might imagine the last few hours before contact. Theia swings in, and Earth tilts ever so slightly toward her. The sun's light catches their surfaces, glinting off molten plains and cratered highlands. Shadows stretch, long then vanish, as each world turns. It is almost a moment of peace, a final inhale before the exhale that will shatter them both. And then in the next heartbeat, they will touch. The first touch is not gentle. It is the slow-motion violence of worlds, the kind that unfolds over minutes, yet reshapes billions of years to come. From the moment Theia's leading edge meets Earth's rock, meets rock at tens of thousands of kilometers per hour. There is no sound space, has no air to carry it, but the energy released is greater than 1 billion nuclear bombs detonating at once. If sound could travel here, it would be a roar that could split the sky. Theia's crust splinters instantly, shards of rock and metal bursting outward in bright arcs. The surface beneath Earth's impact point liquefies, glowing brighter than the sun for a moment as molten fountains rise higher than mountains. Imagine the shock wave. It moves not through air, but through the very bones of the planet, racing around Earth's circumference, in minutes shaking every ridge and rift. For Theia, there is no turning back. Her entire leading hemisphere crumples inward under the force. Huge chunks of her mantle tear free, flung into space. Some pieces sail off into the void, forever destined to wander as nameless meteoroids. Others begin their new life as glowing droplets in orbit around Earth. If you could see this from afar, it would be terrifying and breathtaking all at once. A plume of molten rock and vapor bursts upward, stretching far beyond Earth's own size, so vast it would make the planet look like a flower, opening in slow bloom. The color would be dazzling, deep reds and golds, from molten rock flashes of white, from vaporized minerals, even eerie blues and greens, where chemical reactions dance briefly in the heat. The impact digs deep. Earth's crust at the collision site is gone in an instant, replaced by a churning ocean of magma. Theia's metallic core, dense and heavy, punches inward like a stone into water. Much of it sinks into Earth's own core, merging their hearts together. If Earth were a living being, this would be a moment of both destruction and strange intimacy, two bodies sharing their most guarded centers. You might ask yourself, how can such chaos create something as serene as the moon? The answer is hidden in the debris now surrounding Earth. Millions of tons of molten rock and vapor swirl outward, forming an expanding halo. Some of it is pure Earth material flung free by the impact. Some is Theia's own flesh and bone. Together they mix into a new composition, already beginning to cool and condense. Down on the surface, if down still has a meaning when the entire crust is in upheaval, the scene is apocalyptic. Lava surges in waves hundreds of meters high. Ash and rock rain down. The air is so hot it could melt lead. The sky is a churning ceiling of fire and dust lit from within by lightning that forks and vanishes in the thick haze. From orbit, Earth now wears a ragged crown of glowing debris, each piece tracing a bright line as it circles. The plume from the impact is still rising, spilling molten material into space like sparks from a forge. In the center of it all, Earth spins on a little slower than before, the energy of her rotation partly stolen by the impact. Her days will now be longer. Theia, or what remains of her, is no longer a single world. Most of her body has merged with Earth or been shattered into fragments. But those fragments have not vanished. They are waiting, caught in the pull of gravity, ready to become something new. In the minutes and hours after the collision, the heat radiating from both planets keeps much of the debris molten, glowing like a necklace of embers. The force of the impact has pushed some of this material into a broad, flat sheet circling Earth, a proto-ring shimmering in the light of the sun. It is the seed from which the moon will grow, and somewhere within that glowing halo, tiny clumps are already beginning to form grains of rock that will gather more grains, droplets that will collide and stick, building themselves toward the sphere that will one day glow in your night sky. In the aftermath of the collision, space around Earth is no longer empty and silent. It is a theater of drifting fire. Chunks of molten rock, some as small as grains of sand, others the size of mountains, arc in slow, glowing orbits. They move like embers, caught in a gentle breeze, except the breeze is gravity, and its pull is anything but gentle. From Earth's battered surface, if anyone could stand there and look up, which of course no one can, the sky would be unrecognizable. A great sheet of molten debris stretches across the heavens, bright as a second sun, in places shimmering red and gold. Every fragment spins, tumbles, and collides with its neighbors, sending sprays of molten droplets outward. It is a slow-motion storm of creation. The heat is overwhelming. Even in the vacuum of space, the temperatures of these fragments are measured in thousands of degrees. Much of the debris glows white-hot before cooling to deep crimson. Clouds of silicate vapor billow upward from the wreckage, forming a ghostly mist that catches the sunlight. Within this haze, tiny droplets of rock spherules begin to condense, each one a potential building block of something greater. If you float far above Earth now, you can see the collision's true scale. A vast, asymmetrical halo surrounds the planet, part ring, part expanding cloud. The inner edge of the debris moves faster than the outer, tracing elegant curves under the influence of Earth's gravity. But not all of it will remain. Some fragments flung too far escape entirely, carrying the memory of the collision into deep space. Others fall back, raining molten fire onto Earth's already tortured surface. You might ask yourself, why doesn't all of it just fall back? Why does some of it stay up there circling? The answer lies in balance. Every fragment is caught in a tug-of-war between Earth's gravity pulling it down and the speed of its own orbit trying to fling it away. When these two forces match just right, the material stays aloft, neither escaping nor falling. This is the nursery in which the moon will form. Somewhere in the swirling chaos, patterns are beginning to emerge. Regions of denser debris pull more strongly on their surroundings, gathering neighbors into loose clusters. These clusters crash into one another, sometimes shattering apart, sometimes sticking together. The collisions are still violent, but each one bleeds away a little energy, slowing the pieces down just enough to merge. Earth, meanwhile, is recovering in her own way. Her spin is slower. Now days have lengthened from 6 hours to perhaps 10. The extra time gives storms more space to grow and lava more time to cool between sunrises. But the surface is far from calm. The heat of the impact still boils, oceans melts rock, and drives volcanic eruptions. If the planet could speak, her voice would be hoarse, but she would say, "I am still here." Theia's legacy is everywhere. Half of her substance now lies deep within Earth's mantle and core, changing the planet's chemistry forever. The rest floats above in orbits that are slowly smoothing themselves into a flat plane around the equator. This is how planets and moons are built, not in sudden perfection, but in the slow settling after chaos. From a great distance, the sun continues to pour light over the scene, indifferent yet constant. Its rays catch the molten spray, turning it into a ring of fire that would make any observer if there were one pause in awe. For days and weeks, the glow of this debris will outshine even the brightest stars. And within this glowing halo, unseen but inevitable, the moon's first heart is beginning to beat, not with sound, but with gravity's patient rhythm. The halo of debris that now circles Earth is a sight unlike anything you've ever seen in your own sky. It is wide tens of thousands of kilometers across, and it glows with the restless shimmer of molten rock. In sunlight, the ring burns with deep oranges and golds. On the night side, it glows faintly red, like the dying embers of a campfire spread across the heavens. This is not yet the moon, but it is the cradle where the moon will be born. The pieces are countless. Some are as small as pebbles, spinning slowly as they trace their orbits. Others are the size of mountains tumbling end over end, their jagged edges glowing from heat that has yet to fade. Every orbit is slightly different. Some fragments circle close to Earth, completing a lap in just a few hours, while others drift farther out, taking days to return to the same point. Gravity is at work in every corner of this glowing ring. Larger fragments pull on smaller ones, altering their paths. Tiny collisions happen constantly, each one sending a spray of molten droplets into the vacuum. Some pieces merge their combined mass, tugging them into a steadier path. Others shatter into smaller shards that then join the dance anew. If you could watch it in fast motion, the ring would look alive, swirling, clumping, stretching, and tightening as it evolves. You might ask yourself, how does chaos like this turn into a single round moon? The process is slow, but inevitable. When two fragments meet and stick together, their combined gravity pulls in more neighbors. These growing clumps act like cosmic snowballs, rolling through the debris field, gathering more and more mass. Over weeks and months, the largest of these clumps begin to dominate the ring. Not all of the debris will become the moon. Some will spiral back toward Earth, burning brightly as it falls through the dense post-impact atmosphere. This fiery rain will last for years, reshaping the surface with fresh craters and lava flows. Other pieces will drift beyond Earth's reach, entirely becoming wanderers in the wider solar system. But the most fortunate, if rock can be called fortunate, will remain in orbit, slowly joining the Great Gathering. The ring itself is changing shape. Initially, the debris was thrown out in a thick cloud, but now it is flattening into a narrow band along Earth's equator. This happens because particles moving above or below the main plane of rotation eventually collide with something else, losing energy and settling into the shared orbital path. Bit by bit, the chaos is being combed smooth. From the surface of Earth, the sight would be mesmerizing. The ring stretches from horizon to horizon, its glow bright enough to cast faint shadows on the ground. When sunlight strikes it at the right angle, the molten surfaces sparkle like jewels, each one reflecting the light in its own fleeting way. This spectacle would last far longer than any human fireworks, months, even years, before the light fades and the ring cools. Yet even as it cools, the work of building the moon continues. Large clumps grow larger, absorbing smaller ones. Some of these proto-moons form close to Earth, but tidal forces tear them apart, recycling their material back into the ring. Only the clumps that form far enough away will survive long enough to keep growing. The largest of these survivors is already beginning to dominate the ring. Its gravity sweeps a wide path clear of other debris, drawing in material with every pass. It is still a molten worldlet, its surface a restless ocean of rock, but it is no longer just another fragment. It is the seed of the moon you will one day know. And Earth, still glowing with the heat of the collision, turns beneath this newborn ring. Her days are longer, her tides stronger, her skies forever changed. The dance between planet and moon has begun, even if the moon is still only a child of molten stone. You drift alongside this molten worldlet as it sweeps through the glowing ring. Its path is graceful, yet relentless, an orbit that pulls it again and again through streams of smaller debris. Each encounter is a chance to grow. Sometimes the approach is gentle. A pebble-sized fragment is drawn in, spiraling down until it merges quietly into the molten surface. Other times, the meeting is violent. A boulder smashes into the side at kilometers per second, splashing arcs of glowing rock into space before they rain back down in streaks of fire. Up close, the young moon is not the smooth, pale face you will one day know. Its surface churns like a stormy sea. Lakes of molten rock bubble and roll. Towering waves of magma crash into one another before collapsing into hissing valleys. Across the surface, jagged ridges rise, where cooler crust is beginning to form, only to melt again when fresh impacts stir the heat below. It is a restless world, still more liquid than solid. From here you can see how the gravitational tug between Earth and this newborn satellite is shaping both worlds. The young moon raises tides in Earth's molten mantle and oceans, while Earth's gravity stretches the moon itself, pulling on its still soft interior. The result is a constant exchange of energy. Earth's rotation slows ever so slightly, and the moon's orbit creeps outward. This exchange will continue for billions of years, long after both worlds have cooled. In the ring, the change is dramatic. The great sweep of the moon's path acts like a cosmic broom, clearing away loose debris. Some of it is swallowed whole, adding to the moon's growing mass. Some is flung outward, escaping Earth's grip entirely. And some is nudged inward, falling back toward Earth in bright, brief streaks. Over time, the ring thins its once chaotic density, now punctuated by only a few stubborn clumps of rock. Not all of these clumps will survive the moon's dominance. A handful grow large enough to be called moonlets, each tracing its own path around Earth. For a while, the sky holds more than one moon. Some of these companions collide with the growing moon, merging into its fiery skin. Others are torn apart by tidal forces, their rubble swept into the main body. A rare few may be thrown into distant orbits, becoming long-lost wanderers of the solar system. If you could stand on Earth, assuming you could withstand the searing heat and choking atmosphere, you would see the moon growing visibly in the sky over decades. At first it would appear as a fast-moving ember racing across the heavens in just a few hours. But as it moves farther away, it slows, becoming a steady, familiar companion in the night. Even then, it glows faintly red for centuries, the last heat of its violent birth fading into the cold of space. Below, Earth's own surface is changing. The constant bombardment from returning debris scars it with new craters. Rivers of lava snake across vast plains. The atmosphere thickens with volcanic gases, turning the sunlight dim and coppery. Rain, when it falls, is hot and acidic, carving channels into still soft rock. This is a world in transition, not yet ready for life, but already preparing the stage for it. Through it all, the moon continues its slow transformation. Its molten surface begins to solidify, forming the first crust. Beneath that crust, the interior remains warm, and active currents of magma reshaping the surface from below. Large basins form where massive impacts punch through, leaving dark pools of solidified lava features that will one day be called Maria by human eyes gazing up at the moon. Eventually, the ring is gone. The sky is clear again, save for the one great sphere that now commands it. The moon has taken shape, its journey from chaos to order complete. But its connection to Earth remains a silent tether of gravity, binding their fates together. Every tide, every eclipse, every slow drift of its orbit outward will be a reminder of this shared beginning. And though the violence of its birth is long past, the echoes remain in the scars on its surface, in the tilt of Earth's axis, in the rhythm of days and nights that life itself will come to depend on. Now, with the last stray fragments gone, the space between Earth and Moon feels calmer. The once flaming skies have dimmed to a deep, dusky orange. The moon, though still glowing faintly with stored heat, is beginning to resemble the world you will one day recognize, round, cratered, and pale under the cool light of distant sun. From your drifting vantage, you can see how the moon's surface tells the story of its violent youth. The largest scars are still fresh, vast basins where mountain-sized rocks slammed into the soft crust, leaving circles hundreds of kilometers wide. The molten rock that welled up to fill these wounds has cooled into smooth plains, darker than the surrounding highlands. These plains, the lunar Maria, stand in stark contrast to the bright, jagged uplands which are peppered with countless smaller craters. If you look carefully, you notice that one side of the moon always faces Earth. This is no coincidence, it is the result of tidal locking. In the early days, the moon rotated faster, but the gravitational pull of Earth tugged at its bulges, creating friction inside that gradually slowed its spin. Now, its rotation period exactly matches its orbital period, so one hemisphere is locked in eternal gaze upon its parent world, while the far side remains hidden. This cosmic dance is so precise that it will remain this way for billions of years. The Earth below is also evolving. With the moon in place, the tilt of Earth's axis is more stable. Without this stabilizing influence, the tilt might swing wildly over time, creating extreme and chaotic climate shifts. Instead, the moon acts as a gentle anchor, keeping the seasons predictable. It will be one of the silent prerequisites for the emergence of complex life far in the future. Still, the environment here is nothing like the Earth you know. Oceans have not yet fully formed. Water exists mostly as steam in the dense, suffocating atmosphere. Volcanoes roar across the continents, spilling lava in glowing ribbons that stretch for hundreds of kilometers. Lightning forks through thick clouds, igniting chemical reactions in the air. It is a restless, breathing planet, its crust shifting its surface, reshaping itself every moment. From time to time, smaller asteroids and comets still arrive, leftovers from the solar system's formation. Most burn away or crash into the moon before they can reach Earth, the moon now serving as a shield against the worst of these impacts. It is not perfect protection, but it is enough to reduce the chaos. In a sense, the moon has already begun its long service to Earth, not just as a companion, but as a guardian. Imagine standing on the still hot crust of this young moon, looking back toward Earth. It would be a mesmerizing sight, a colossal blue-black sphere swirled with red and orange from molten continents and veiled in streaks of white steam. The Earth would dominate the sky, appearing more than 13 times larger than the moon does from your own era. Slowly, over millions of years, that sight will shrink as the moon's orbit carries it farther away. Beneath your feet, the moon's crust thickens. Its interior, though still active, is cooling, and the once molten surface becomes more rigid. The basins and craters freeze in place, preserved like fossils. Without atmosphere, wind, or water to erode them, these features will remain almost unchanged for the rest of time. They will bear witness to cosmic events for billions of years, a record of impacts and collisions that will be lost on the ever-changing Earth. And yet, despite this slow quieting, the gravitational link between Earth and Moon is still a source of subtle change. The tides on Earth continue to push the Moon outward by a few centimeters. Each year, an invisible expansion of their shared orbit. In return, Earth's days lengthen ever so slightly, its rotation easing as the ages pass. This is a slow trade, measured not in human lifetimes, but in the slow heartbeat of the cosmos. If you stay long enough, the moon will dim from fiery orange to soft gray, its heat dissipating into the cold void. It will become the familiar sentinel of the night sky, though in this age no eyes will yet look up to see it. Life is still far in the future. For now, the Earth and Moon continue their silent waltz through space, bound together by the ancient violence that forged them both. Time slows here not in the sense of clocks, but in the rhythm of change. What were once violent daily transformations now stretch into thousands, even millions of years. You linger in the vast silence above Earth, watching the molten glow fade from the moon until it becomes a cool, stony orb. Its craters, still sharp-edged and new, seem frozen in mid-breath, as if the entire surface has agreed never to move again. Below Earth is still restless. Huge volcanic arcs ripple across the continents, belching ash into an already thick atmosphere. The sky remains heavy with steam and carbon dioxide filtering sunlight into a deep amber glow. But beneath the chaos, there is a slow and steady shift. Oceans are beginning to form. The steam that once roared skyward with every eruption now condenses, falling as rain for centuries at a time. Great sheets of water gather in low basins, carving rivers and shaping coastlines in their infancy. The moon watches all this from its lofty perch, locked forever in its gaze toward Earth. This constant companionship begins to shape more than just the tides. The gravitational pull of the moon acts as a kind of invisible clock for the planet, creating cycles, rhythms of ebb and flow that will one day govern not only oceans, but the patterns of life itself. Even now, the tides are fierce, far greater than those of your own time. With the moon much closer than you know it, its gravitational force pulls enormous bulges of water toward and away from it twice every day. Imagine coastlines where the sea retreats dozens of kilometers, leaving wide plains glistening in sunlight, then surges back with unstoppable speed. These extreme tides stir the young oceans, mixing their waters, spreading heat, and carrying nutrients to every shore. Occasionally you glimpse a flash in the sky, not lightning, but impact. Smaller asteroids and comet fragments still slip through the moon's guard, striking Earth or the moon itself. Each collision sends ripples through the still-forming crust, changing coastlines, raising mountains, or creating new craters. On the moon, every such strike leaves a permanent mark, another chapter in its long geological diary. From here, you can sense the bond between Earth and Moon deepening. Tidal forces continue to slow Earth's rotation, lengthening the days from just over 10 hours toward the 24-hour rhythm you know. The slowing is imperceptible in the moment, but over millions of years, it will transform the length of daylight, altering the pace at which life evolves. If you shift your focus to the far side of the moon, the hidden face that will never be seen from Earth, you find it even more pockmarked with craters. Without the constant pull toward Earth, its crust here is thicker, more rigid. This asymmetry is a quiet reminder of the moon's birth. The near side facing the planet retains more of the lighter materials from the molten disk, while the far side is built from denser remnants. The space between Earth and Moon is far from empty. Fine dust from past impacts still drifts here, forming a faint, shimmering veil when sunlight catches it. This cosmic dust dances in long, looping arcs, pulled alternately towards the planet and the moon. Eventually, most of it will settle, either drawn into the moon's gravity or falling into Earth's atmosphere, burning up in brief flashes as shooting stars. And so the violence fades into a kind of fragile calm. The moon's path grows more stable, its orbit slowly widening. Earth's oceans deepen, clouds whiten, and volcanic fury softens. The first hints of a blue sky appear as carbon dioxide levels gradually fall and water vapor condenses into permanent seas. You could almost believe the solar system has reached a peaceful balance. But you know this is only the middle of the story. The forces at work here are still immense, still shaping not only landscapes, but the conditions for life. The moon remains both witness and participant in this transformation. its silent pull guiding tides, stabilizing seasons, and keeping Earth's spin steady enough for the improbable miracle that will one day follow. It is strange to think that this great turning point, the collision, the molten birth, the cooling, and the settling, was only the prologue. The moon has done its first work, it has survived, taken its place in orbit, and begun to shape the destiny of its partner planet. But its role in Earth's future has only just begun. The world below is still wild, but its violence is now punctuated by long stretches of quiet, the kind of silence that feels like a deep breath before something new begins. From your vantage above, you watch as Earth's crust, once thin and molten, grows thicker and more stable. Entire plates begin to form vast slabs of rock that will one day drift across the planet's surface, colliding and pulling apart in slow-motion dances that shape continents and ocean basins. These early tectonic movements are small compared to the grand rearrangements to come, but already they are carving the face of the planet. Mountain ranges rise where plates push together their jagged peaks, still steaming from the heat below. Long rift valleys open where the crust is stretched thin, filling with the water that now falls almost constantly from the sky. Rain hammers the still young rock, breaking it down into fine sediment that washes into the seas, painting them with mineral-rich clouds. The moon, closer than ever, casts its pale light over these changes each night. Its pull is so strong that the tides do more than shift the water, they knead the entire planet. The crust flexes under the gravitational tug, subtly shaping volcanic activity and stirring the molten rock below. It is as if the moon's invisible fingers are still helping to mold the newborn Earth. But the relationship works both ways. Earth's gravity also tugs relentlessly at the moon, creating tiny bulges in its shape. Over time, these constant stresses have a curious effect. The moon's rotation slows until it becomes tidally locked, always showing the same face to Earth. From this point forward, no matter how much time passes, only one side of the moon will ever be familiar to human eyes. The far side remains hidden, a secret half-world that only spacefarers millions of years in the future will ever see. The hidden side, however, is not untouched. Even as the moon's rotation halts, meteors still slam into it, some leaving craters so deep and wide they span hundreds of kilometers. These scars never fade. There is no atmosphere to weather them, no wind to smooth their edges, no rivers to carve them away. Every impact is preserved for eternity, a fossilized moment of cosmic violence. Earth's own surface is less permanent. Volcanoes continue to erupt, mountains wear down under rain, and ocean tides gnaw at the shores. From high above you can see how the tides, amplified by the moon's closeness, surge far inland, then retreat to reveal vast mudflats teeming with potential. Here in these tidal zones, the constant mixing of water minerals and chemical compounds creates a rich soup, the kind of environment in which life's earliest building blocks could form. The moon is already shaping the stage for life without knowing it. Its gravity keeps Earth's axis of rotation steady, preventing wild swings that would turn seasons into chaotic extremes. With the moon's stabilizing presence, Earth will avoid the fate of other planets, where axial tilts wobble dramatically over time, causing climate patterns to veer unpredictably. This stability is a quiet, uncelebrated gift, one that will give the fragile beginnings of life a chance to endure. The light from the sun is changing too. The thick atmosphere, once choked with volcanic gases, is beginning to clear in patches. The sun's rays pierce through in golden shafts, warming the young oceans. Storms still rage often, but in the calm between tempests, light spills across the water in shimmering pathways. On the moon's surface, This same sunlight reflects back toward Earth, bathing the nights in a glow far brighter than the modern full moon you know. And always there is the slow drift. Each year, the moon moves ever so slightly farther away from Earth, just a few centimeters at a time, but over eons this will amount to vast distances. The tides will weaken, the days will lengthen, and the moon's apparent size in the sky will shrink. But for now, it is close enough to dominate the horizon, a looming sentinel that seems to watch over the planet's transformation. If you close your eyes here in the silence of space, you can almost feel the heartbeat of this new Earth, the steady rhythm of tides, the deep rumble of shifting plates, the distant thuds of impacts on the moon. It is a young, raw world, yet one already guided by the invisible partnership between planet and satellite. You know, though, that this is only the beginning. The stage is nearly set for the first sparks of life, and when they come, the moon's influence will be written into their very existence. It is not just a companion in the sky, it is a guardian, a clock and a sculptor, and its work has only just begun. Now the oceans are no longer empty. They shimmer in the daylight, their surfaces curling into long, glittering swells under the pull of the moon's gravity. With every rise and fall of the tides, the shorelines breathe, drawing the waters inland, then retreating to expose damp sand and tide pools. These shifting boundaries between sea and land are more than just geological curiosities. They are restless laboratories. Here in the warm shallows and salty puddles, chemistry is at work. Lightning forks across storm-darkened skies, striking the surface of the water with a hiss of steam. Each bolt carries energy enough to break and reform molecular bonds. From the stew of dissolved minerals, simple molecules join into more complex forms, amino acids, lipids, and the primitive chains of nucleotides. They drift and swirl in the briny mix, waiting for the right sequence of events to spark something entirely new. The moon's role in this quiet alchemy is subtle but crucial. Its tidal rhythms stir the waters, concentrating these chemicals in certain pockets along the shore. Pools left behind by the receding tide heat in the sun, evaporating slowly until their contents are more densely packed. Then, when the tide surges back, the pools are flooded again, replenished with new material from the sea. This constant cycle, wetting, drying, mixing, becomes a natural engine for creation. Above the moon's face glows in the daytime sky, pale against the blue. You watch its slow journey from horizon to horizon, and you notice how it seems to whisper its pull to the oceans, like a conductor guiding an unseen orchestra. Without this steady hand, the tides would be weaker, the mixing less intense, and the fragile experiments of life might never find the conditions they need. Meanwhile, the Earth's crust continues its slow dance. Volcanoes pour molten rock into the seas, creating black, glassy islands fringed with steam. Underwater vents gush scalding water, rich with metals and chemicals from deep within the planet. Around these vents, you can almost imagine the first microscopic cells clinging to life, tiny sacs of molecules wrapped in delicate membranes, dividing and multiplying in the mineral-rich darkness. The atmosphere is shifting too. Volcanoes still vent clouds of carbon dioxide, nitrogen, and sulfur, but water vapor now dominates the skies. Rain falls more gently than in the planet's violent youth, feeding rivers that snake down to the oceans. The air is thick, but not yet breathable for the creatures that will one day walk the land. Still, it carries the scent of minerals and the tang of salt, an invisible record of the world's earliest days. The moon itself is quieter now. The heaviest bombardments have passed, and only smaller meteors still pepper its surface, from time to time adding fresh scars to the ones already etched in stone. Each new crater catches the light differently, changing the subtle patterns you see when its face is full. It is no longer a world in chaos. It has settled into its role as a constant presence, a clock in the heavens marking the passing of days and months. If you were to stand on its surface now, you would see Earth hanging in the black sky, huge and blue-white, swirled with clouds. From here, Earth does not rise or set. It stays fixed in one place, turning slowly, always showing the same side to the moon, just as the moon shows one face to Earth. This locked gaze is an unbreakable tether, a bond that will last for billions of years. Back on Earth, the days have already grown longer. The newborn planet once spun so fast that a day lasted only a few hours. But now, thanks to the moon's steady braking force, each day stretches closer to the familiar rhythm you know. The slowing spin will continue for ages, lengthening the days even more. But here, in this early era, the change is already enough to alter the pace of weather tides and the gentle heartbeat of life. Night falls again. The moon, swollen and bright, rises over the water. Its light spills across the waves in a silver path that seems to lead straight to its surface. The tides follow its cue, rushing in to cover the sand swirling around rocks and islands sweeping through the tide pools where the chemical dances continue unseen. In the stillness, it feels almost deliberate, as if the moon is patiently, quietly coaxing the planet toward its future. And in a sense it is. Without knowing it, the moon is midwife to life's first steps, its gravitational pull a constant touch shaping shorelines, guiding oceans and giving the smallest of cells the rhythms they will one day carry inside them. The night stretches on the stars, wheeling slowly overhead, and you realize you are watching the birth of something far greater than a planet and its satellite. You are watching the birth of a partnership, one that will shape every wave, every season, every living thing that will ever emerge on this world. The moon's light lingers through the night, casting a pale glow over the restless seas. Under this soft illumination, the first fragile membranes enclose themselves into tiny bubbles protocells. They are nothing more than microscopic sacs holding a soup of molecules. Yet inside them something remarkable is stirring. Molecules begin to copy themselves, not perfectly, never perfectly, but well enough to carry information forward. These imperfect copies are a gift, for in their flaws lies change, and in change lies the possibility of adaptation. Some protocells rupture, in seconds their contents spilling uselessly into the water. Others hold together longer, giving the molecules inside more time to react, bond, and form the earliest threads of biochemistry. The moon, from its high perch, continues its work without knowing. The tides it calls shape the boundaries of these early life experiments. As the sea rises and falls, protocells are swept into new environments, sometimes destroyed, sometimes enriched. Each tide is a trial, and each retreat leaves survivors more suited to the world they inhabit. Your gaze shifts upward. The moon is not entirely motionless. It wobbles ever so slightly in the sky, a gentle oscillation called libration. From Earth, this allows you to glimpse just beyond the edge of its familiar face, though never the whole hidden hemisphere. It is a reminder that even the most constant things still hold secrets. Below, volcanic islands grow and fracture. Their black sands gleam under moonlight, and the waves lap gently against their shores. In tide pools warmed by the sun during the day and cooled at night, simple metabolic reactions take root. Some protocells begin to trap energy from chemical gradients, tiny imitations of processes that billions of years later will power the beating of your own heart. Occasionally, the still young moon catches the shadow of a passing meteor strike, on Earth a burst of light, followed by curling plumes of vapor. But these impacts are no longer the cataclysmic planet-shaping events of earlier ages. Now they are sparks, sometimes destructive, sometimes seeding new minerals and organic molecules into the oceans. The Earth's rotation continues to slow, but now the change is gentle. The tides are no longer the massive surges they once were. Instead, they become more rhythmic, more predictable. This stability matters. Life, however primitive, thrives on cycles, light and dark, flood and ebb, warm and cool. Without such steady repetition, the delicate balance required for life's persistence could falter. Night after night, the moon turns these cycles like clockwork. Its phases crescent, half full and back again, create patterns of light that will one day guide migration's reproductive cycles and even the myths of early humans. But for now, its glow simply bathes the waters, where life stirs a silent witness to their quiet experiments. As dawn approaches, the moon dips toward the horizon. The stars fade one by one, and the sea glows with the first hints of morning. In the shallows, some protocells have managed to persist for days, perhaps even weeks. They are still far from the complexity of true life, but the seeds are there, compartmentalized chemistry replication variation. You realize that this moment in time is like the pause before a deep breath. The world is stable enough for fragile things to endure, yet dynamic enough to keep pushing them forward. The moon ensures this, holding Earth in its gravitational embrace, keeping its axis steady, its tides lively, and its rhythms intact. Without this partnership, the path ahead might be far more chaotic. But with it, the stage is set. The first chapter of life's long story is about to turn. The morning light spills across the ocean in molten gold, and the moon, though now hidden beneath the horizon, still tugs invisibly at the waters. You feel the pull and the rhythm of the waves, in the measured breathing of the tide as it creeps in and slips away. The Earth has entered a gentler age compared to its chaotic youth. Volcanoes still erupt, their black smoke curling into the sky, but the constant bombardment of space debris has slowed. Between these fiery outbursts there is calm, and in that calm, the oceans work their quiet alchemy. In shallow pools along rocky coasts, sunlight penetrates the water, with ease heating it during the day and cooling it at night. This temperature shift acts like a cosmic heartbeat, pumping energy into chemical reactions. Molecules link together, break apart, and reassemble. Over countless cycles, these reactions begin to form more stable patterns. Some protocells, by chance, manage to harness these cycles to replicate more reliably than others. They are not alive as you understand the word, not yet. But they are no longer just drifting chemicals. They are systems, tiny self-sustaining loops, fighting entropy for just a little longer each day. Above them, unseen, the moon's gravity keeps Earth's axis from wobbling wildly. Without this stability, climate patterns could swing into violent extremes, freezing seas one millennium and boiling them the next. Instead, the moon holds Earth's seasons steady, giving these delicate proto-life forms a fighting chance. It is a silent collaboration, though neither partner knows it. The moon does not choose to nurture Earth. It simply follows the laws of motion, the echo of that ancient collision that bound the two worlds together. Yet its presence shapes the conditions on which everything else depends. Far inland rivers wind their way toward the sea. Some carry minerals from deep in the crust, washed free by rainwater that has carved valleys over eons. These minerals join the ocean's mix, providing nutrients for the ever-growing web of reactions. Iron, phosphorus, sulfur, they slip into the tide like ingredients in a recipe still being written. The tides themselves are the great stirrers. They slosh these chemicals through bays, around islands, into estuaries and back again. They mix, they blend, they spread opportunity. On days when the moon is full or new, the tides are stronger. Spring tides pushing farther up, beaches flooding tide pools and carrying their contents into new niches. Some protocells are swept into places where they dry partially in the sun, only to be rehydrated by the next wave. This drying and wetting acts like a forge, strengthening their molecular bonds. In this constant motion, Earth becomes a laboratory the size of a planet. Millions of experiments run in parallel, each driven by a combination of sunlight, mineral chemistry, and the moon's ceaseless pull. Most fail within moments, but some endure. The enduring ones are the seeds of all that will follow. Occasionally, storms roll in from the open sea, stirring the surface into chaos. Lightning splits the sky, discharging raw energy into the water below. Some of these strikes trigger reactions never before seen, producing rare molecules that might otherwise have been impossible to form. The moon's tidal influence means the storms hit different shores at different times, spreading this rare chemistry far and wide. The sun rises higher now, burning off the morning mist. If you could zoom far into a tide pool, you would see a miniature cosmos protocells bobbing in warm water, molecules darting in and out of their fragile membranes. Some protocells even interact with each other, swapping bits of their inner chemistry. These exchanges are clumsy, random, but they hint at a future where life will share, compete, and evolve. You sense that something irreversible is approaching. For billions of years, Earth has been shaped by blind physical processes, gravity, heat, erosion, magnetism. But now a new kind of process is emerging, one that can adapt, remember, and change on its own. And still high above the moon, follows its path, utterly silent, utterly steady, unaware of the role it is playing in the dawn of life. The seas are no longer just water and salt. They are archives. Every molecule that has formed and survived is part of an ever-expanding chemical library, a record of what has been possible under the laws of physics and chance. Day after day, the sun pours energy into the surface waters. At night, the moon takes over, not with light, but with motion, its gravitational pull reshaping the shorelines, stirring the oceans, forcing every coastal microworld into constant renewal. You feel the rhythm now like a slow breathing across the planet, the inhale as water creeps upward with the tide, the exhale as it slides back to the sea. In one shallow bay where volcanic ash has settled into soft, mineral-rich mud, this rhythm becomes something more. The mud's surface is cracked from cycles of drying each fissure, forming miniature trenches. When the tide rolls in, these cracks fill with seawater, carrying the latest soup of molecules and protocells. When it rolls out, the water retreats, leaving some of the contents stranded, trapped to bake in the heat of the day. The drying concentrates the molecules, pushing them closer together, forcing interactions that, in dilute seawater, would have been too rare to happen. Some protocells gain tougher membranes from this cycle. Others develop crude ways of harvesting energy from light or chemistry in the mud. Most fail, collapsing into formless debris, but a few endure, and endurance is everything. In another part of the world, perhaps thousands of kilometers away, the same dance is unfolding in a different key. Here, black smokers, hydrothermal vents, spew hot, mineral-rich water from deep beneath the crust. Around them, the sea is a cathedral of darkness, but the vents themselves are alive with heat and chemistry. Molecules cluster around iron-sulfur surfaces, snapping into new configurations. Some protocells drifting near the vents adopt these mineral coatings as crude shells, making them more resistant to the chaotic environment. The moon's tides pull the surrounding water back and forth, subtly circulating these molecules, ensuring that vent chemistry does not remain isolated but becomes part of the global experiment. It is in this mingling tidal mixing storm, surges, volcanic outflows, that the improbable becomes inevitable. A protocell emerges with an internal chemistry that allows it to make crude copies of itself. The copies are imperfect, each with slight variations. Most of these variations make no difference. Some are worse, making the protocell less stable. But a rare few are better, more resilient, more efficient, more able to persist in the face of the world's chaos. And with that, the slow but unstoppable engine of evolution grinds into motion. This is not yet life as you know it. There are no cells with nuclei, no organized DNA chains, but the principle is the same. Variation, selection, persistence. The first quiet spark of biological time has been struck. From this moment on, Earth's history will be split into two eras: the age before replication, when change came only from the shaping hands of physics, and the age after, when the changes will come from within. The moon continues to watch, aloof and cold, bound forever to the planet it helped sculpt. Each tide it raises now serves as both a destroyer and a creator, washing away fragile early structures in one place, only to seed their descendants in another. Without realizing it, the moon has become an architect of possibility, writing in water and salt, erasing and redrawing until something lasting appears. Above the seas, the air is thick with volcanic haze. Rain falls more often now, feeding rivers that churn with sediment, and minerals feeding the coastlines with fresh raw material. And always the cycles repeat: the push and pull, the wetting and drying, the mixing and separating, until protocells are no longer rare visitors in the tide pools, but constant inhabitants. They drift in sunlight, they cluster in the dark, they divide, they fail, they begin again. It will be millions of years before they evolve into anything that could be seen without a microscope, and billions before they walk the land, gaze upward, and wonder about the moon. But even now, in these silent beginnings, the bond between Earth and its satellite is sealed not just by gravity, but by the shared story of life's first breath. The oceans have become a vast stage for a play with no audience, at least not yet. Currents coil and uncoil, storms whip the surface, and deep beneath the waves, the chemical actors continue their endless improvisation. The moon's pull ensures there is no stillness for long. Even the calmest lagoon feels its invisible hand. In the shallows, protocells crowd the edges of tidal flats, riding the foam back into pools that will trap them when the tide slips away again. Many of these pools are shallow enough for sunlight to reach their bottom, scattering gold through the water. Here, some protocells have stumbled into a chemical quirk: pigments that can absorb the sun's energy and use it to drive their own internal reactions. This is not yet true photosynthesis. It is crude, wasteful, and fragile, but it offers an edge. Those with pigments linger just a little longer before their membranes collapse. Elsewhere, life's chemistry experiments in the opposite direction, away from light. In vents and deep sediments, protocells adapt to thrive without sunlight, drawing power from reactions between minerals and surrounding water. Some form loose, slimy mats, early whispers of cooperation, where being near one another increases survival odds. The moon's tides are the great matchmaker. They scoop up bits of vent life and deliver them to shore. They lift coastal protocells and fling them into deeper waters. They take the chemistry of one world and shake it into the chemistry of another. These chance meetings, violent, random, but constant, are where novelty is born. Most new combinations fail spectacularly. Some membranes dissolve instantly. Some protocells burst in the salinity shift. But every so often, something survives the journey. And once something survives, it can spread. In one quiet inlet, a few protocells learn a trick: they do not fully separate after dividing. Instead, Two or three remain tethered, sharing a thin membrane bridge between them. The connection is accidental, a byproduct of an imperfect splitting process, but it allows the cells to exchange certain molecules more easily. If one finds itself in light, its pigment reactions can feed its neighbors. If another stumbles into a nutrient-rich patch, the benefit passes along the link. These clusters are still fragile, waves can break them apart, but in calmer pools, they last longer than solitary protocells. Over countless cycles of tide and storm, the habit of staying connected becomes more common. By chance, cooperation begins to root itself in life's story. Far offshore, in the mid-ocean, swells chains of simple cells start to appear. Not intentional, not designed, but formed because certain membranes naturally stick together after replication. A chain can be caught in a current and carried farther than a single cell ever could. If the chain survives the journey, it seeds new places with its members. You can almost feel the clockwork of the planet, turning sun overhead, moon, tugging at the sea's continents, shuddering with volcanic breath. The early Earth is a place where every force is in excess. Too hot, too cold, too acidic, too violent. And yet life keeps finding tiny corners where the balance holds just long enough to take the next step. Storm season arrives in the equatorial oceans, and waves taller than buildings crash over coastal flats, obliterating countless protocells. Yet in the chaos, some are driven into hidden rock cracks filled with seawater. Protected there, they divide in safety, and when the next tide floods the crevice, they spill out into the world again. The moon watches all of it, with unblinking patience. It does not choose which survives. It merely stirs the pot, ensuring the ingredients never settle. Without its pull, the seas might grow still, stratified and lifeless. With it, they are forever restless, a perfect cradle for trial and error. Already the ocean's chemistry is shifting. Waste products from one protocell become food for another. Chains become mats. Mats become fragile films that coat rock and sediment. In a few rare cases, films survive the full cycle of tides, storms, and seasons. They hold on just long enough for the world's first stable ecosystems, tiny, microscopic, and ancient, to take root. These early cooperations are the faintest prelude to the great chorus to come. One day the descendants of these films will build forests, coral reefs, and civilizations. But for now they simply cling, divide, and endure little more than chemistry, with ambitions it does not yet understand. And all the while, the moon keeps time. Its pull is the silent metronome against which life's first experiments unfold, marking each tide not just as a rise and fall of water, but as a heartbeat of an entire planet. You drift now into an epoch where the ocean's chemistry hums with a quiet urgency. Billions of tides have come and gone since the moon's first pull set the waters in motion, and the experiments seeded in its cycles have grown stranger, more intricate. In some warm shallows, mats of cells have become denser, their members press so close that they begin to specialize, not by intent, not by any guiding mind, but because the conditions inside the mat differ from those at its surface. Cells on the outer rim face the brunt of sunlight, waves, and predators, while those deeper within live in dimmer, calmer conditions rich in waste products and nutrients washed inward. This subtle division of labor means that in time, the mat is more than just a random gathering. It is a community with roles, however rudimentary. Elsewhere, chains of cells have learned to bend, curl, and fold into shapes that catch light more efficiently or trap drifting nutrients. Some resemble tiny spirals, others crude cups or tubes. The shapes are not planned, they are accidents preserved because they happen to help. The moon's tides remain the great distributor of these experiments. A storm surge might rip part of a mat away and carry it to an entirely different shore. Sometimes the fragment withers in alien chemistry. Sometimes it thrives spectacularly, filling a new niche. The ocean becomes a patchwork of habitats, each with its own flavor of life. Beneath the surface, evolution's clock ticks in fits and starts. Many of these early communities collapse suddenly. A shift in temperature, a burst of salinity, or the arrival of a new, more efficient competitor can erase millions of years of slow adaptation in an instant. But extinction clears the stage for new performers. With every collapse, the survivors spread into the emptied space, reshaping the ecosystem. A breakthrough begins in a cluster of cells bound together more tightly than most. This bond is not just physical, it's chemical. The cells share tiny channels in their membranes, allowing molecules to pass directly from one to another. Nutrients flow more evenly through the group, and signals primitive bursts of chemical change ripple across their network. These signals are not language as you would know it, but they are coordination, and coordination changes everything. One such cluster drifts into a tide pool, survives the evaporation of half its water, and waits in the remaining brine until the moon's next flood refills the basin. This resilience gives them a foothold in a world of constant change. Over thousands of cycles, the habit of staying connected becomes not just common, but essential. The moon's light at night plays a quiet role here too. In the shallows, moonlit tides allow certain cells to time their reproduction to moments when they are most likely to be carried to new ground. Even without eyes or minds, life begins to respond to a rhythm that is neither day nor year, but month, the moon's own calendar woven into biology. And then by chance, as always, some groups begin to produce sturdy outer shells. These are simple, nothing like the armored creatures that will one day crawl from the seas, but they shield the cells inside from bursts of heat, dryness, and predators. The shell changes their relationship with the tides. No longer must they divide only in the gentlest pools. Now they can survive in rougher, more exposed flats. These shells also allow them to travel farther. A wave can roll them across sandbanks into rocky clefts, even into the mouths of streams that lead inland. For the first time, the ocean's living chemistry brushes against the edge of the land, testing a new frontier. Yet for all these advances, life is still small, fragile, and mostly invisible. The world above the volcanic peaks, the endless storms, the glowing night sky remains untouched by it. The air is still thin and alien. But beneath the moon's patient gaze, the blueprint for something greater is being drafted one tide at a time. In deep time, these patterns will spiral into creatures with bodies, senses, and appetites. But in this moment, they are still quiet architects laying the foundations for futures they cannot imagine. The moon's pull unchanged, since its fiery birth continues to mix, scatter, and reunite them forever, the unseen partner in life's earliest dance. The moon still rides high over the young earth, its pale face scarred by ancient impacts. Its orbit steady, but subtly slowing as tidal energy bleeds into the planet's turning body. Each night, it traces its silent arc across the black, silvering the waves below. Those waves are no longer merely salt water and minerals. They are crowded theaters where life rehearses its next act. By now, the ocean's surface is threaded with shimmering films of cells, more complex than their ancestors, yet still far from anything you'd call an animal or plant. They are colonies with internal rules. Some cells focus on drawing energy from sunlight, others on absorbing nutrients from the water, and still others on forming protective barriers around the group. Within these clusters, cooperation has edged toward dependence. Individuals can no longer thrive alone. The tides in their relentless cycle have pushed life into every corner of the shallows. They've swept colonies onto sun-baked flats, where survival means enduring long hours of exposure, and into shadowed rock pools where temperature shifts like a heartbeat. In each place, new strategies arise. Some organisms build stronger shells. Others grow tiny hair-like filaments that let them cling to stones. Still others develop ways to store energy for leaner days. And always the moon's rhythm guides the choreography. The monthly pulse of high and low tides becomes an environmental clock, one that even the simplest life follows. Some release spores or reproductive cells only during spring tides when the water will carry them farthest. Others time their growth to phases of gentle flooding, avoiding the chaos of the strongest surges. Without eyes, without minds, they have become creatures of the moon. Deep beneath the surface, in quieter waters, something astonishing begins. Certain cells begin to enclose parts of themselves in membranes, creating specialized compartments. These compartments allow them to run different chemical reactions at the same time more efficiently than before. It is a step toward the architecture of complex cells, the kind that billions of years later will form plants, animals, and you. In the same era, some life takes its first hesitant steps toward multicellularity. Here and there, colonies stop breaking apart after reproduction. Instead, they remain joined their offspring, bound to their parents, forming bodies of dozens, hundreds, even thousands of cells. They are still microscopic, but they represent a leap in possibility, communication, coordination, division of labor. The moon's tides, by endlessly fragmenting and recombining, have selected for groups that can endure together. Now and then the tides carry these colonies into brackish water at a river's mouth. There they face a strange new chemistry, less salt, more silt, different minerals. Many die within moments, but a few linger, adapting bit by bit. Each generation becomes slightly more tolerant of this halfway world between ocean and fresh water. Though the land is still barren, these are the pioneers that will one day help bridge the gap between sea and shore. Night after night, the moon shines on this slow transformation. Its light is not the architect. Gravity and chance hold that role, but it is the ever-present companion. In the darkness, under moonlit ripples, fragile new forms pulse with life. They are the inheritors of the collision that tore the moon from Earth, the beneficiaries of tides stirred by that cosmic scar. From here, the story will accelerate. Over millions more years, these colonies will diversify wildly. Mats will grow thicker and taller. Some life will take root in deeper waters, and others will edge toward the coasts, testing dry land. The world's chemistry will shift in response, oxygen rising and skies clearing. The moon's work, steady, patient, unceasing, will remain a gravitational heartbeat, guiding every tide and every leap forward. You, floating in this deep time dream, see the whole arc at once, from a molten earth struck by a wandering world, to a glowing moon hung in the sky, to the first whispers of organized life stirred by its pull. The tides have been the invisible hands, shaping everything, mixing, scattering, uniting, and testing life against the edge of survival. Without them, without the moon, this ocean might still be silent. But it is not silent now. It sings in chemical pulses, in drifting spores, in the delicate brush of a filament against a grain of sand. It sings in the rhythm of the tides, a music written in gravity. And though the future is still hidden beyond uncountable years, the melody is already playing, the same one that much later will cradle you to sleep beneath a silver moon. If you've enjoyed this journey, I'd be quietly grateful if you'd give this video a like or tap that subscribe button for more peaceful explorations with the Sleepy Scientist. It helps more than you might imagine. And before you drift off, I'd still love to know, where in the world are you listening? From what time it is there? Leave a comment if you're feeling cozy enough to share. It's always a quiet joy to see this sleepy little community ripple across time zones and continents. Good night,